So let's take a look at our problem of the day for this great Thursday afternoon. To simplify the expression, an expression is in parentheses 3x minus 4y, and then you've got another parenthesis 4x plus 3y, which means we're going to multiply those parentheses together. Two binomials multiplied together. So we're going to simplify the expression of 3x minus 4 in a parenthesis times 4x plus 3y. Did I put a y on that other one? There is. There is a y on two different things, all right, there. So let's take a look and see what this thing is going to work like for us, all right? Now, first of all, so many times we look at this, they're not plus and there's not a minus in between here. When they're jammed together, these parentheses jammed together, it's a multiplication. It's multiplication. Now, what we are going to do is we're going to play the distributive property. And what we're going to do, we're going to take that 3x and we are going to make sure we get everything, I love to say hit, but multiplied, we'll say, into everything in that second parenthesis. So here we go. We start with 3x, and we're going to multiply it times 4x plus our 3y. Now, at this point, we want to make sure the 4y, this minus 4y part right here, gets also its fair share of distributive property working for it. Sometimes I call this the double-barrel distributive property. But what we're doing, we're going to say a negative 4y, and we're going to multiply that by 4x plus 3y. There we have it. It's set up, ready to go. Ready to go here. Let's see what's going to happen when we do our distributive. Notice I've already mapped the arrows, but let's map them right here. All right, we're going to say first 3x times 4x. Now, keep in mind, this is a place where students make mistakes a lot of times. You get the 3 times 4 right. Okay, that's going to be 12. And x times x gives us x squared. Don't forget your squared. Sometimes students and adults tend to leave that squared off. We just don't think about it. But x times x does give us x squared. Now let's follow the arrow one more time out there to 3y. And we're going to have 3 times 3, which is going to pick up a 9. It's going to go positive. And I have my little x and I've got my little y there. They just come together, just happy as can be. We'll call it xy. All right. X and y, of course, stand for numbers. They could be the same number. More likely, they're probably going to be two different distinctly numbers. And let's see now what we're going to do. We're going to distribute this minus 4y through the pattern here. That's going to give us a negative 4 times a positive 4, which is going to give us minus 16. Boy, I get my tongue tied today. And we'll put an xy attached to that. There we go. All right, so far so good. And last but not least, hey, we've got this 4y times 3y. And once again, as I did a minute ago, we're going to watch our signs because it's a negative times a positive. It's going to be a negative 12 or minus 12. And we got to make sure we have y squared on the end. Now you say, Ernie, are we done? Are we done? Well, not exactly. Not quite. Let's take a look and see what we can put together. I see some like terms. Now, the variables and their exponents must match identically. Notice here we got an x squared and a y squared. They stay separated. They aren't the same variable. They are the same exponent, but not the same variable. So keep them separated. In the middle, we have an x and we have a y. The coefficients 9 and minus 16 are not important to us. They're going to join together. But the xy is basically saying this is like term situation, all right? So we are able to put those two little guys right there in the middle. They're going to come together. They're going to be ones that come together. So we're going to keep 12x squared all by its lonesome up here. It doesn't go anywhere. Sorry, Gav. And then we're going to pick up negative 16 plus 9, which is going to give us a minus 7. Keep this xy rolling along for the fun of it. And then we've got minus 12y squared. All right. That's where we're going on that. That's one option. There's another way we can do it. How many of you have heard, of course you can tell me, right? How many have heard of doing what we call the FOIL method? So I'm going to rewrite this problem here, right down here at the bottom. I've got 3x minus 4y, and we're going to multiply it times 4x plus 3y. Now what the FOIL method says is that we're going to go first, outer, inner, last. In other words, we're going to do a mental process that basically runs this double-barrel distributive property right through there, all right? Let's see how that works. First of all, the first terms are 3x times 4x, all right? That's going to give us 12x squared. Well, guess what? That's what we started off with doing the double-barrel distributive property, right? So let's go to the outer level here. We've got this 3x and 3y multiplied together. Well, goodness sakes, how about that? It gives us that 9xy. Go inner. The inner ones, by the way, are the 2's with the 4's, all right? The 2 terms with the 4 here. We've got a minus 4y times a positive 4x. We're going to get minus 16xy. And once again, you see those like terms popping up. And then we get, on the tail end, last. L stands for last. So first, outer, inner, last. Those are our 4 words there. And that will give us minus 12y squared. I want you folks to notice, got the same results, just a different option. Put those together, and we have 12x squared minus 7xy, and then we got the minus 12y squared. Same response, same answer, both times, a little different approach. What works for you, let it work for you. Another thing I want to point out that you could do with the foiling, you could have done that, you could have kept that 9 and negative 16 in your head and just put them together and go straight from the parentheses straight to the answer. Do a little mental math going on there. So a good way to get us started off here, that is our problem of the day.